Don't forget to record. Okay. First thing I wanted to tell people, I think did I mention the office hours thing last class?
Mm-mm.
No,
No, you said you didn't know last time.
no. So now I do.
Yay.
Office hours at least, and might as well just give you guys sort of the update for math lab as well. Give me a second. Okay. Let me switch to. Do I still have it open? Yes, I do. Oh.
I just ordered an amp.
Hey. That means you're gonna have a fun weekend if it gets here quick enough, at least.
It says it's gonna come here on the 28th.
Hey.
That's in a week. I'm sure it'll probably be a little faster.
Yeah.
I don't know. Everyone in quarantine. Everyone's pretty busy.
Amazon never fails to come through for me though.
All right. So this is the sort of like the main page for our class, right?
Mm-hmm.
Yes, sir.
I've pretty much, by and large, sort of stopped updating this.
Yeah.
Yeah. Since February 25th, we're almost a
2
almost
months after that.
a month off of that already.
Oh.
I tried. I think everybody's using my notes more than anything. So what I wanted to do is I wanted to, first of all, keep using the course notes. So that's right here. The thing that I wanted to point out was this.
You're cutting out.
Yeah, somebody's mic is a little loud here. Was it Raymani? Think it might have been. Okay. So what I wanted to point out is this spot right here. This is going to be sort of the way that we're going to run our online office hours from now on until we're able to go back to school. So this link right here takes you to a Zoom meeting. And during my office hours, I'm going to be there. So long as you click on this, let the thing open up. And if I'm there, you'll see me there. Okay. The questions now is, when am I going to be in my sort of virtual office hours? And that's where I put this thing. It's the door card that, if you guys remember from the scavenger hunt, whenever it wants to load. So you guys remember from the very first day when you guys did the scavenger hunt, you guys had to go look at this, right? This is the schedule for me throughout any 1 week, right? I'm gonna be following this still throughout the whole quarantine. Got it? So for right now, we are in here. Right here.
8 a.m.?
Yeah. I'm gonna.
It's only 45 minutes.
Yep.
Okay.
Well, that's how it was before. And then after class, I still have office hours. So afterwards, if you guys go to that link, come on. Afterwards, if you guys go to that link, you'll find me in my office, virtual office.
So like on Friday, would you have the online office hours all day?
Yep, I'm gonna have online office hours this Friday. So tomorrow, I'll have office hours all day. I'm just gonna be on Zoom.
So are you going to minimize the requirement, or is it still going to be 36?
We haven't talked about it yet, but we're still trying to figure out how to implement lab hours again, just so that you guys can have a spot where you can go and ask questions.
Just because it's it's a lot less flexible, I guess. And I mean, we can only go to yours? Like, there's no way we can just do a math lab, like, if there's another teacher?
So yeah, so that's what the other thing I wanted to get at right now. Let me. Right, okay. So what I want to do is I want to go back to not there. There. I'm gonna go back to my So my canvas looks like this. So if you guys go to your dashboard, this thing up here, so mine looks real busy because they've got lots of stuff to do. You guys maybe have maybe 3, maybe 4 squares,
Mhm.
right? So I think the work or the method that we're going to be using in terms of giving you guys sort of a virtual location for a math lab will be through Canvas. So what's going to happen, hopefully, the idea is that we're going to start it on Monday. You guys see this box right here? We're currently still testing it out. So on Monday, hopefully this box right here, the one that says Math Lab, LMC Pittsburgh Math Lab, it's going to show up for you guys. And what you guys are going to do is whenever you need to go to the Math Lab, you go ahead, click on it, and this will open up. And this is going to be the schedule of the Math Lab, at least online, for the foreseeable future. Does that make sense? So notice that my office hour or my Math Lab hours still match up to everything that's here, right? So Monday or Tuesdays and Thursdays from 8 to 8:45, I'm here, right? And then you don't see me again until Mondays and Wednesdays from 1:15 to 2. And then Fridays, practically all day. Got it?
Yeah, so when you have it, we just have to be in there, right? We don't have to
Right.
ask any questions or anything.
Right. So you come to this. So you go to your Canvas, right?
Yeah.
You're gonna go to your Canvas. You're gonna look for the LMC Math Lab one. You go in. You look at the time. So right now it's Thursday 1 o'clock. So then that would be about right here. So if you go into the Math Lab right now, you would probably see Mr. Ramos and Miss Seppi in class right now, or in the Math Lab. Does that make sense?
Yeah.
I know it feels a little wonky. It might feel a little weird, but it's the best thing that we can do for now.
It says 12,000 per adult.
Fair enough.
All right. We good? Okay. So what I want to do now is I want to get started with the stuff for today. Okay. So for today, I want to do module 12.2, 12.3, and 13.1. 12.2 deals with an empirical rule. So it's the way I like to describe it is we want to know how our data behaves, right? And it's a sort of like a really quick, it's a really quick rule that we can use to at least get rough estimates to what we need. Okay. Next comes z-scores. So if the empirical rule was the sort of like the quick and dirty, really quick, rough estimates, the z-scores is sort of the much more precise, the fine tuning of finding out what your data does. Let me see. Okay. And then the very last one is 13's, module 13.1. It's the beginning of study design. So this is something we haven't been able to do yet in terms of discussion, what to do with you guys have a project that you guys need to do. We haven't figured out what to do with it yet. Hopefully by the end of today, or hopefully by next week we'll know going to go down with it. But module 13 deals with beginnings of study design. If you want to research a question, right? How do you go about designing a study? Right? How do you go about creating the question? How do you go out and get your data? How do you go and analyze your data? Once you do finalize sort of some conclusions from your data, how does that, how can you interpolate that, or how can you expand that explanation to everybody else? So we're about to get into inference. We're almost there, okay? In terms of the mathy parts. All right? Okay, so what I want to do now, let's say, like I said, I wanted to start with 12.2. I'm letting my thing think. It's a nice sunny day outside.
What's the outside?
Outside as in just outside in the world.
It was pretty cold last night.
It was. So I have an AC in my room. Now I had it off, but the AC itself, the machine had a temperature gauge on it, and it was 60 degrees inside my room at night. So I was in PJs. Okay, so the first thing I want to do, like I said, this is going to be a study for the empirical rule. And in particular, it's going to be a bit more of a sort of what the normal distribution does, how it behaves. I think I gave a quick definition of what a normal distribution looks like last class. It's single hump, looks like got it? There are three things that we've been using to describe our distributions. It's the shape, the center, and the spread. And for a normal distribution, you have something very specific for all three. So the shape for it is always going to be bell-shaped. So it's always going to look like this bad boy over here. Okay. It is going to be symmetric, which means that the mean and the median are going to be equal things now, right? And they will always be right there, smack dab in the middle. So this point right here is the mean, and it is also the median. Got it?
And it's gonna always be like that?
It is always going to be like that. The mean is always going to be that middle hump.
Okay.
Okay. And then lastly is the spread. And this is where we start connecting the stuff from what we've been doing for the last couple chapters to now. The standard deviation is what defines our spread. So depending on how big or how small our standard deviation is what tells us if our hump or our normal curve will be like really, really tight together or really, really spread out. Cool?
Mm-hmm.
A little bit of nomenclature, so how we name things, right? We're going to start using these two Greek letters. So this one over here is like a U with a little tail. It is the Greek letter mu. And
you
this symbol right here, which looks like an O with a tail. And that's sigma. So usually, this is now sort of like a quick aside. So when mathematicians start naming stuff, we first start with the English alphabet, right? if we think we ran out of letters from the English alphabet, we go to the Greek alphabet, hence the reason why these are Greek letters.
Wait, does that say MU?
MU, yeah, mu.
Wait, but didn't the Greeks create things like geometry and stuff?
Yes.
So then wouldn't it all just be like in Greek to begin with?
Not well, current mathematics. Let me put it that way.
That's it.
Yeah. Let me ask you guys this. This is one that people don't haven't completely heard of yet. What letters do we use once we run out of Greek letters? Does anybody know the answer to that one?
Pi?
Huh?
I don't know. I said pi, but that doesn't make sense.
No, well, pi is a Greek letter, so that's not exactly. So after we run out of Greek letters, what alphabet do we use in math?
The Latin? I don't
Huh?
know.
Nope, not Latin.
Isn't that the same alphabet as ours? I don't know.
I'm pretty sure everybody's like, yeah, I don't know. I have no clue. The answer is, let's see, there's a submission through the chat. Russian letters. Oh my. It's not Russian.
You have to be real desperate to use Russian letters.
Right, there'd be forward and backwards R's and upward down V's and I don't know what else.
Is it Hebrew? Don't they have like a whole different
That's right.
thing in them?
So after math runs out of Greek letters, we go to the Hebrew alphabet. And in the Hebrew alphabet, I only know of one thing that requires that, which is Aleph.
And what is that?
So Aleph has it's
The squiggly line of dots.
yeah, it's supposed to be. I think I wrote it wrong.
Yeah, I think so too.
Looks
think-
like a percent.
I think I can't remember. So this letter is sort of like we treat it as pi, and like E, it has an actual specific value that we refer to. But that's a fun fact. Why would you guys want to know a math fun fact?
Math isn't fun to begin with, so how can you have a fun fact?
How dare you?
It's the truth.
I've had this conversation with a lot of people. It's hard to make math fun if you're not going really fast or blowing something up. Yeah. All right. So we're gonna get in some practice here. So for the normal curve that's been given, we want a mean of 6 and a standard deviation of 2. So this middle one will be what?
6.
And what would this one be? What would this be? And what would this be?
4 and 8.
Oh no.
Yeah, 4 and 8.
No.
Upward.
It'd be 8, 10, 12.
8, 10,
Right.
12.
Oh, okay.
8, 10, 12. So the standard deviation is 2, right? So that means every gap here has to be 2. Right? And then the ones in the opposite direction?
4, 2, 0.
Right. So it's going to be 4, 2, 0. Wait, I'm sorry. 4, 2, 0. So each one of these gaps is 2. Got it?
So far.
Okay. What's the mean for this one, and what's the standard deviation for this one? For the one below it, number 2.
30 and
30
10.
and 10.
Right. Make sense?
No, you get that. How we get that?
So the mean is always the middle hump, whatever that is, right?
Right.
And that's 30. And each one of these is 10 big, right?
Right. Okay.
And that's how we get our standard deviation. Cool?
So 30. So the mean is the U, and the O is the what is it? Standard deviation.
Standard deviation, which is sigma.
Yeah.
Okay. The empirical rule. Okay. This is what I had mentioned at the very beginning. This is our quick and dirty. If we need to describe our data somehow, we use the empirical rule. The other way that nobody remembers to call it the empirical rule. Most people call it this thing, the 68, 95, 99.7% rule. Okay. So the way that the 68, 95, 99.7 rule works out is we use our standard deviation, and from our standard deviation, we know how much data should live within 1, 2, or 3 standard deviations. So specifically, if you look between 1 standard deviation away from the mean, you have 68% of your data. So between 1 standard deviation away from your mean. You guys see that?
Mhm.
There's the middle hump, right? That is always going to be your mean, right? If you go 1 standard deviation out from your mean, if you go 1 standard deviation out from your mean, that much data, so all of this, all of that would be 68% of your data. Got it?
Yeah, I really love the colors.
I know, I'm digging the colors. I can't believe other instructors aren't doing this.
What, using colors?
Using color and just using this thing online or using a tablet. Between 2 standard deviations, so between here and here, 95% of your data will lie between those 2 values. So if you look anywhere between here and here, all of this is 95% of your data. Notice I am leaving out the very last ones, right? Within 3 standard deviations of your data, of your mean, that's where 99.7% of your data lies. So if you're between here and here, so from here all the way on to here, all of this, all of that will be 99.7% of your data.
What color is that?
So what happened to the other
That's
point
my-
3?
That's my spaceman. So
We
that's
don't talk about that 0.3.
So that's a good question, Leon. We do talk about it, but this is probably going to be it's a very, very light topic here. So you guys see the graph? Does this graph end at 3 standard deviations away? Like it's supposed to end. Let me ask you guys that. Can you be, how about this? Can you be 8 standard deviations away from your mean?
No,
Why not?
because you would be over like 100% of your data.
So
You can't have over 100%.
So technically, that's the misconception that I want to sort of nip in the bud right now. So the real interesting stuff. Let me actually make my pen a little bigger. The real interesting stuff happens within 3 standard deviations. Yes? But that doesn't mean that nothing exists outside of 3 standard deviations. So this graph actually just keeps going in both directions. Does that make sense?
Mm-hmm.
So you can have mu minus 4 sigma, mu minus 5 sigma, mu minus 6 sigma, right? In this direction. And you can have the same thing over here, right? You can have mu plus 4 sigma, mu plus 5 sigma, mu plus 6 sigma. Does that make sense? So the graph keeps going in both directions. Is there going to be a lot of data in those directions?
No.
No. Most of it lives here. Specifically, most of it, almost all of it, lives between 3 standard deviations away. Got it?
Okay.
I don't really know yet. It's kind of weird, but I guess.
I can dig it. Let me erase my scribbles. I'll leave the color coding for...
Online stuff is really just not it.
Huh?
This online stuff is not it.
Yeah, this shit sucks.
Yeah, like just from I don't know. I just can't really focus. I guess like I don't know.
You know what I noticed happened to me earlier today?
Mm.
I tried to I was thinking of doing like I needed to prep for you guys, and since I was already at home, like I looked around and I was like, oh, I need to do that, and 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 then randomly I thought, oh crap, I'm supposed to be in office hours. And turns like when I came back to look, I saw Chase and I think somebody else was in the. So I got distracted from prepping for you guys.
Am I the only one that can barely hear Julia?
Your volume's probably
Yeah, turn up your volume.
It's all the way up.
It's all the way up.
All the way up.
Get a speaker.
What kind of laptop you got?
MacBook?
Oh, I don't know. I have one too. Mine's
There's
fine.
your problem.
Yo.
Get that new software update without getting the next.
Oh no, I'll never download a new software. I don't got time for that.
Let's see.
I really just like don't. I really think I just have to go watch this lesson again after class because
Fine. I need to I'm still trying to update them, so don't worry about that. How about this, Sam?
What?
Wonder. Oh wait. Oh, it's automatically setting.
What's up?
Do you hear me better now?
Like the tiniest bit.
How about
I
now?
tried connecting to my speaker, but I think if I connect to my speaker, like when I talk, it sounds all like muffled and shit because it comes from my speaker, not from me.
Okay. Yeah, that might do it.
I tried to put my AirPods in, but they fucking. I mean, I curse way too much. I'm sorry, they died.
070 to the accused, class 1.
All right,
Okay.
say something.
No. Okay. So while you try that, I'm gonna keep going. Maybe you can debug while I keep going. Yeah. Okay.
Will we ever work with more than 3 sigma on either side of the mean for this?
By and large, no. Simply because of that thing that I told you, right? Most of your data is going to live between here and here anyway. There's very little on either end. So that's, I think, I guess that's the best thing. That's what I want you guys to take away from this. By and large, you will be working between here and here. There is data outside, but you won't be looking at it very much, almost at all. Does that answer your question, Weston?
Yeah, I was just wondering.
Okay, so weights of 1-year-olds are normally distributed and have a normal curve. Mean is 22.8, and the standard deviation is 2.2. Let's go ahead and label this bad boy. I know it looks tight for you guys. We'll try our best. So what's this middle hump?
22.8.
Right, so this is going to be the mean no matter what. So 22.8. So give me the 3 above it.
25, 27.2, 29.4.
25. And what's the next one? 27.2?
Yeah, and then 29.4.
And then 29.4. I don't know why my pen is not. There we go. So notice each one of these, right? From here on is 2.2. 2.2. 2.2. Which is exactly our standard deviation. Got it? And what are the ones below it?
20.6.
And then it's a 17.4?
18.4.
18.4. No, I think that's not enough, isn't it?
It's 2.2, right?
Yeah, 18.4.
And then 16.2 for the last one.
There we go. Same argument. 2.2, 2.2, 2.2, which are supposed to be standard deviations. Got it? Okay. What is the probability that a randomly selected 1-year-old lies between 20.6 and 25? So we are looking.
68.
How much?
68%.
Right.
I mean,
So
yeah.
we want everything in between those two, right? How much data is in between these two? All this.
68%.
68%. And that we are getting directly from this thing, right? Within one standard deviation, we are guaranteed that 68% of data. Got it? What is the probability that a randomly selected 1-year-old boy weighs more than 25 pounds? So we need everything from where?
25 to the right.
Right.
So 16.
Yep. So how'd you get 16?
Because there's 32% left outside of both or one standard deviation away, and then you have to divide that by 2.
Exactly. So let me actually go ahead. I'm going to use a big area here to show what the heck is going on. So I'm going to replicate my normal. So that 25 is 1 standard deviation away, correct? Between 1 standard deviation, how much data is there?
68.
How much is it again?
68%.
Right, this is supposed to be 68%, correct? That's supposed to be everything.
What's up? I'm hold on. Hold on.
So that's 68%, right? How much is left outside?
32.
Exactly. Does that make sense?
Mhm.
So for both of these is 32%. Got it? How much is in just one end of it?
16.
Huh?
16%.
What color is it?
And that is our answer. That's the 16% that we're looking for.
Connor.
And the way that we got our 16, right, is both of these together is our 32. We only need one of them. So divide by 2, we get our 16. Got it?
Yep.
Okay. But really quick, which probability represents the larger region, A or B?
It's the same.
A.
So somebody said
Because
B,
the
somebody
numbers
said
are-
they're the same. Which
Oh, wait,
one?
no,
They're
they are the
both
same.
within like standard deviations.
Because like the bottom numbers are different and the ones on the side are also different, but like they kind of balance each other out, I guess. Does that make sense?
How so?
They're
What do you
both
mean by
normal.
they're out, huh?
They're both normal, so and they're the same standard deviation, like away out from the mean. So the
Exactly.
percentage of values is the same.
Exactly. So the means here, right? The means are still 5, right? And if you look at the standard deviation that's been given, so this is 1, 2 standard deviations away, and this is 1, 2 standard deviations away. Same thing here. That's the standard deviation here. This is 1, 2 standard deviations away, 2 standard deviations away. Got it? And the rule still works out. 2 standard deviations away, no matter what, is 95%. So both of these have 95% of your data. So they're exactly the same. How we doing?
Catching up.
Okay.
Wait, what does that say?
Have 95%.
Huh? Oh no. Someone else needs to write this for you. Oh, there you go.
Yeah.
Suddenly learned how to write.
Hey.
Only on occasion when
Only-
asked.
Yeah.
Yeah. If you can.
Whoa, you cut out there. All right. Group work. How many group work assignments do you have? Oh, just the one. Okay. So what I want you guys to do, I'm gonna stick you guys in groups. So you guys can try out these group problems in your groups really quick. After we come back from groups, we will go to break. Sounds like a solid plan?
Sure.
Yep.
Okay. So for your groups, once you get into your groups, go ahead and do problem number 5. We'll come back in maybe 5 minutes to discuss them. Let me see, breakout rooms. All right. Head on to your groups.
Okay.
Am I the only one who there? Okay.
This Zoom.
Me either.
I don't like it at all.
Yeah, no one does.
I'm just drop out.
Please don't. Please don't.
Oh, Jesus.
I didn't know he was in here. Me either.
Somebody, I think it was Weston in here. He said that yes, I think the last class I made you guys do group work again.
They got the green screen.
And yeah, you like it? You like it? And last class he said that when I popped into their group, I scared the shit out of them. Because they started talking and nobody knew I was in here. Which I thought was funny. So same thing with you, Ray. So I held off as long as I could, but I needed to get another bag of these.
What's that?
There you go. The Trader
Wow.
Joe's like, chips or
Wow.
whatever. Yeah. All right. How you guys doing with this one?
Wow, we got a raise our hand button. Wow.
Hand button.
Wow. I like this a little bit more.
Yeah. And it blinks on my end.
Wow.
Hey.
All right. So it seems like you guys are still sort of getting settled in. I'm gonna let you
Yes.
with it, so I don't scare you guys. I'm gonna go terrorize another group.
Okay.
The green screen.
Right.
Let's see. What group should I go to? Oh, I'm gonna scare Sammy. I see you, Sammy.
What's up? Yo.
Yo.
What the fuck? How'd you do that?
Background. So if you go to your video, there's a little caret right next to stop video. Click on it, and there should be an option to, what is it? Choose virtual background or something.
Wait, so I click the caret and I see select a camera, FaceTime HD video settings.
There's a little caret.
Yeah.
Right next to it. And it says choose desktop or choose something background. Let me see.
All I have is select a camera, FaceTime HD camera, and then video settings.
Oh, you don't have virtual backgrounds.
I mean, hold on.
There should be an option for virtual backgrounds. All right. How you guys doing with this one? Number 5.
Number 5.
Pretty good, pretty good.
What'd you guys get for
Takis?
Huh?
Takis?
The Trader Joe's Takis.
Disappointed.
Huh?
I'm disappointed.
Well, I do have regular good old ones, but these are dang good.
Really?
Yeah. Let me turn off my virtual background so you can see them because it thinks it's part of my background. There you go. These.
Oh damn, those look good.
They are so good.
I respect it.
Yeah. All right. Back to NSYNC. How you guys doing with this one?
Pretty good, pretty good.
Okay.
Just I'm having trouble with 5B when it says what is the range for normal birth rates by this definition. Because I got 5A, I got 32%.
So here. Oh. Yeah. Okay. So we say stuff is normal if it's within 2 standard deviations. Right? If it's within 2 standard deviations, we call it normal. So in order for the first bullet point for B, we want to know how probable is it to have a baby weight, right? To be normal, which means to be within your 2 standard deviations away.
Which is 99.79, what, 73?
Close.
99.73.
Close. You went too far. That's 3 standard deviations.
Oh, 95.45. So what is the range?
Then you give me my ranges. You give me whatever +2 and -2 standard deviations are, right?
But how far do we go right and how far do we go left?
2 standard deviations.
No, but the mean is 120, so we go from the right to 140, 160, 180, 200. We can keep on going.
Yep.
So how far do we go right and how far do we go left?
2 standard deviations.
Good help.
Good help.
Wait,
how much is 2 standard deviations above the mean? What does that mean you do?
95%.
Well,
and then you split it in half, so that's
20,
47 and 20. Something like that.
So, Ruben's question was, what's the range, right? So, how far up is 2 standard deviations away?
40.
Right.
So
40 above.
Isn't the range just? I'm sorry, I wasn't here for the first part of the lesson, but so tell me if I'm answering the question wrong. But isn't the range just like all the numbers and captured by like the study?
Within 2 standard deviations.
Within 2, like the normal distribution, yeah.
Yep.
And is that like, okay, so is that like a question specific thing, or is like, so normal is always 2 standard deviations, but the range is just in this question asking for within 2?
So normal distribution is the shape of your data. So am I still sharing the packet with you guys, or you guys see my pretty face?
Seeing your pretty face.
Okay. I need to share my. There we go. Okay. Let me share my screen again. So normal distribution deals with how these shapes are, right? It's the spread that's defined by the standard deviations.
Okay.
Does that make sense? So within 2 standard deviations, you know how far 2 standard deviations is. So you grabbed your 20, right? And you multiplied it by 2. That's your 40. That's 2 standard deviations away. But it's supposed to be 2 standard deviations above your mean.
Okay.
And I give you the mean.
Wait, isn't
So
that
it's 120 to 160.
Close.
It's 40.
It's 40. So go 20 above and 20 below, or 40 above and 40 below.
160 and 80.
Exactly.
And then so my range is 80.
From 80 to
160, which is 80? But how'd you get that?
This this online shit sucks, man.
Yes, how did you get that though?
How'd I get that? That's my standard deviation. That's my mean, right?
Yes.
I needed to go 2 standard deviations above and 2 standard deviations below my mean.
So
One standard, go ahead.
So how'd you get to 160 though? Is it 20 times 2?
20 times 2 gets you 40, right? That's your 2 standard deviations.
Okay. And
now you have to go.
You just subtract 120 by 40 and subtract 120. Well, add 120 by 60.
By 40.
120 by 40.
Yep. Got it?
So whenever it says 1 deviation or 2 deviations, you just times that 1 or times that 2 by the actual number of the deviation. Okay. Got it.
Yo.
Got it now.
Okay. I'm gonna go scare some more people.
All right.
I love scaring people. I'm saying, huh? Not join.
I did the bottom of birth rates more than something.
Yeah. All right. I'm gonna go scare some other people.
All right.
Peace out.
Peace. No. I'm here.
Hi, Julio.
Hello.
Oh, you're in our group.
I just bounced them.
Okay.
Oh, what'd you guys get?
We, for the first one, we said the probability is 16%.
How'd you get that?
And the same thing we did on the one before. You were only looking at the left side of so you had the 32%, made up the total from the 68%, and then you were only looking at the left side. So we
right
that there too.
Yep. Did you guys get through B and C yet?
Yes.
Okay.
For B, the first one we said 95, 0.45%.
Right. And what was the range for it?
80 and 160.
Mm-hmm.
And then for C, we weren't too sure, but we said like about 2.5%.
Yep.
Perfect.
Yep. You know what you're doing.
I don't.
Well, who was that? Was that Madison?
No, that was me and Allie. I'm like lost, but like I don't know. It's probably just I can't focus where I'm sitting.
Somebody in another group just said the same thing, that they were they're distracted because now they're at home.
Yeah.
That's definitely usually a problem for me as well. Like I distracted, from people being in my house, talking, family, TV, or even me just doing this in my bed, I want to take a nap.
So in my previous class, so I had what class was it? Intermediate algebra right before you guys, maybe about an hour before.
Mm-hmm.
And maybe like 20 minutes before class ends, It's quiet. So I'm like, okay, everybody's paying attention. Cool. And all of a sudden I hear in the background some kid go, "Stop, I'm playing Minecraft." The whole class started laughing. And it was one of my students has like a younger sibling that doesn't have to go to school. So they're just at home playing Minecraft.
That's funny.
My God. No,
Yeah.
that's my mom. She was just like, no, we're gonna go pick up some stuff that they left at my aunt's house. She's like, I'm taking your brothers so the house is quiet and you can do your work. I'm like, thank you.
Yep.
She told me to sit in the kitchen, but we have roosters and they've been going off since class started. I just hear them. I'm like, my room is much quieter. I'll just sit here.
Yeah. I know.
Julio,
Mm-hmm.
do you ever play or you know about? I don't. My brother does. Dungeons and Dragons.
Oh my God, D&D.
D&D. I do know D&D. I've never played it before though.
Okay, I was watching my brother, cause him and his friends like would usually meet and play it, but you know they really can't right now. So they played online, and
Yeah.
they live streaming it, and then he sent it to me. So I was watching them. I had no idea what was going on, but I was watching because it was interesting.
Yeah.
It's online now.
An old tutor of mine used to be dungeon master. He still is. And he has fun with it. He goes real crazy with it. He makes like little trap rooms. He makes like scenarios that makes his people think or whatever. So
Yeah, pretty cool. I like called my brother after and was like, "Can you explain that to me? Like, what was even happening?"
Right.
Yeah, out of nowhere, you have to solve that.
Yeah. All right. I'm gonna bring everybody back now
Okay.
because I need you guys to go take a break.
Yep.
Okay. See you guys in a bit.
Right.
Whoa.
Gnarly, bro.
That was the longest 10 minutes of my life.
That was
exactly 10 minutes, actually. I sent you guys out at like 1:41.
Dude, I don't know why, but like right before you did that, my stuff like it stopped working. So like what you were showing, like it just froze up and then it kicked me out of the like meeting. And then it brought me right back in when you were.
That's weird. It shouldn't do that.
Time for a break.
No, well,
Yeah,
let's cover
I'm
this.
honestly done. So good night.
Good night. Let's cover. Let's do this one. It shouldn't take more than 2 minutes, and then we'll do break.
Oh no, we didn't get. Did we do number 5?
Not yet. We're about to.
Oh, okay.
And since it's just one, we should be done so quick. So quick. All right.
It'll take 2 minutes. We can add another 2 minutes for a break.
Yeah. All right. What do people get for number A or for letter A?
16%.
Likely that it is less than 100 ounces.
Right. So.
Oh, we're supposed to put it into context.
I mean, I did.
Yes. So, this is going to be sort of like from here on out. Whenever you have questions like this, don't hesitate to actually like draw a normal distribution out and label it. Does that make sense? Oh. So 1, 2, 3. 1, 2, 3. So my mean is
120.
My mean is 120. Up and down. So let's do the top 3. 140, 160,
180.
180, and then downward.
100. Yeah. 80, 60, and 40.
Right. We don't have to go down to 40. We can, but we don't have to. So no matter what, don't hesitate to draw one of these. Right? So the question was asking 100 down, right?
Yeah.
Need all of this. How much is in here? How much is in here?
30%.
16.
32%.
It's one of those.
16.
16.
Why is it 16?
Because it's half of
Because it's only
32.
half.
Maybe one half instead of both.
Right. So how much data is, let me do the other half really quick. How much data is in between the two right here?
68.
There is 68 in between, which means how much are in the outsides?
32.
32.
No. 16 because 68 plus 32 is 100%.
Right. So
half of that is 6. So half
Right.
of one side is 16 and the other half is
right.
100 and below 16.
Both of these combined are 32%, right?
Mm-hmm.
Which means one of these singular, just 16%. Make sense? I'm gonna use the space pen.
The space pen.
My space pen. Okay. B. Probability. Randomly selected baby is normal. Normal weight.
95%.
Right. This is going to be 95%. So it says up here, normal birth weight is everything within 2 standard deviations of the mean.
Mm.
So how much data is within 2 standard deviations?
95%.
95%. What's my range? What's my lower and upper bound for that 95%?
80 to 160.
80 and 160.
Right. From 80 to 160. So we need everything from here all the way over to here, right?
Mm-hmm.
Because that's within 2 standard deviations. Got it?
Yeah.
Okay. Doctors define low birth weight as a birth weight more than 2 standard deviations below the mean. So.
Oh, sorry, 5%.
2.5%.
Right, 2.5. Yeah. So I'm going to draw another one really quick. 120. So we need 80 and 160. How much data is in between these two?
%.
Right. So this right here constitutes 95% of our data, right?
Mm-hmm.
How much data lives outside?
2.5.
Exactly. It's 5 all together, right?
Yes.
So all together, both of these are 5%. So how much is just one of them?
2.5.
Right. We just divided in half. How we feeling?
Good.
Cool.
It's pretty easy so far.
It's not bad, right?
Yeah.
Yeah, I think this is working pretty well too, like relatively for the circumstances.
Yeah. This online business?
Yeah.
Yeah. Yep. Okay. I want to move on to 12.3, but before we do that, potty break, go get something to eat break, snack break, whatever you need it. Go take a break.
Well, thank you.
Uh-huh.
I've never been this bored in my entire life.
You've never been this bored in your entire life?
Yeah, I have my PS4 loaded up. I've been playing on it the entire time.
Yeah, see,
Wow.
this reminds me of when I was in school.
A million years ago?
Huh?
Oh my god.
500,000.
I've been like support.
Huh?
I'm joking.
Oh, I didn't even know what you said, Sam.
Oh, I said like 5 years ago since you're so young.
Yeah, kind of actually. I think you might be right. There were times like when I was in school when and this would happen like at around summer school, right? Or during the summertime, where I was tired of doing everything. Like I had already played all my video games, beat them a bunch of times. I was tired of playing my guitar. I was tired of doing this other stuff. So I was
You
like,
play guitar?
yeah, I've got one. It's over there.
Isn't that your band right there behind you? You're in the middle, right?
Huh?
That's your band behind you.
No, it's not. Actually, that's a painting from my wife wanted a painting up there.
Oh.
I should show you guys what my room looks like. Don't worry, it's all here. Let me see.
Jesus.
I need to turn off the thingamabob though. Let's see. Need to turn off the virtual background so that everybody sees where the heck I'm at. I'm actually on my couch.
Oh.
I'm on my couch.
Can somebody else turn their video on?
They can.
What do you mean they can't?
As in, they can.
Wait, can you guys see me?
Yeah.
Oh.
I think you can't turn on your, what is it called, the background or whatever, the virtual background. That I don't think works.
Because I'm like not the instructor person.
Not the host.
Yeah. I mean, let me see. Meetings turn off.
Nah, everyone can do the background thing.
I can't.
Oh.
If you go to choose a virtual background, it doesn't give you one.
I don't have that.
It's next to start video.
I don't. Okay, so it says stop video and then the caret. It only goes select the camera, FaceTime HD camera, and then video settings.
Yeah, it doesn't give them an option for virtual background. That is weird. That is weird. Whoa. Remote control of my shared content, huh? I'm going to decline that one.
Why? Dude.
I actually try it. I think people tried it before. You guys, okay. Let's see.
Wait, so can I? Oh. Wait, hold on.
Oh, try clicking the, you see the little, so you see the space pen?
Yeah.
Space pen.
Space pen, click the space pen. And then click the little hand that's like two symbols over. That one. Now try it.
Oh my god.
That's pretty cool.
Hold on, let me write something. It's not going to be what you think it is, I promise.
Oh my god.
Follow me, hi.
Wow.
Are you putting your Twitter tag on there or something?
This is my IG tag. I want all the clout.
Somebody was saying I should I think it was in this class. Somebody's like, you should that I should make with a Twitch handle or whatever, and just lecture that way while I.
Oh yeah, you just stream on that, John.
Wow.
Just go in creative mode.
I just got booted out. That was weird.
Wait, you got booted out?
Yeah. I think it's because I was enabling my camera.
Mm,
So you could look at my beautiful picture.
yeah.
When was your birthday? You going?
No, but Deadaye's following me. I don't
Wait,
care if
hold
I
on.
follow. Whoever said no, it's your bum ass. It's your monotone head ass.
Got a problem with bummy asses, huh?
What'd you say?
Got a problem with bummy asses, huh?
With what? I can't hear
Bummy
you.
asses.
Whoa. Are we gonna virtually throw down here?
I want all this. I'm actually back in New Jersey.
Mm. All right. You actually brought up a good point.
What?
Well, no, I just remembered something. Right now, I think you guys got maybe another 4 minutes left of break, so afterward, I'll mention it.
What is it about?
These lectures.
Oh.
These are good. Go back to
So far, you're the only teacher that's doing lectures.
Huh?
So far, for me, you're the only teacher that's doing lectures on Zoom.
Same.
Yeah, it's kind of nice.
a bunch of instructors have they've gone to what's called asynchronous mode. That all the communication is being done through email. They're not doing any sort of online live thing like this. It sucks.
I know my other teacher had this problem, Julio, but whenever he recorded his last lecture, he recorded it to his desktop. I don't know if you have it saved to your cloud or not, but he made that mistake. It's like, I'm going to have to upload it onto YouTube for you guys.
Yeah, so that's the thing I was going to point out. So I'm going to give you guys maybe 1 or 2 more minutes.
Oh, did you kick me off?
Yeah.
Also, I had a question about the Zoom lecture things. My teacher don't know how to show off his work, on the Zoom.
Wait, say it again.
You do the actual writing, and then we can actually see that. But my teacher doesn't know how to do that, show off his work.
Oh, that's easy. So I don't know how you guys would do it, but for me, there's you guys know how you guys have a little toolbar or Zoom that sort of hangs out on your desktop? It should say something like, you have your little mic thing and then a stop video, controls, and all that stuff, right? There should be an option that says remote control.
The remote control about to start.
Huh?
I said the remote control.
Yeah. So, and if you click on remote control, it'll send me a message saying, hey, this dude wants to remote control your computer. And then I say yes or no.
And then you get a virus that lets them do it at any time.
Yeah. Well, I think you can type stuff, and you can type stuff, and you can write stuff, but I don't think you can send me an app. I did share it, right?
Hey, y'all can see me? Clear and everything?
Yeah.
Hey.
We can see you.
Can we?
Wow. I'm black.
If you want to believe that.
How you gonna mute yourself?
Huh?
Oh shoot!
So if you hit the mic button, or if you hit the
Next to the record button.
it's all there. All right. You guys ready? I'm actually gonna. So in your guys's while you guys are out, make sure you open up your Stat Crunch. We're gonna need it.
Right now?
I have to
Yep.
turn on the
I'm
computer.
gonna show you guys what to do. Eventually, you will need it for your group work. Just an FYI.
I need you can't supply.
That would be fun, wouldn't it?
Mm-hmm.
Let's see. Yeah. That's why. I think I can. Yeah, I can. Okay. Cool. All right. You guys ready?
No.
I know.
Yeah.
All right. Like I had mentioned before, right? Let me erase all this Sammy stuff. Okay. Like I had mentioned before, the thing that we did before, let me stop my video. The thing that we did before was, like I said, the quick and dirty, right? If we needed quick estimates, we used 68, 95, 99.7, and we got nice values, right? They're not exact, but they're pretty darn close, right? Module 2.12.3 deals with what's called standardization and Z skills. Okay, so the idea behind standardization is um, that we basically standardize values so that we can compare them. Does that make sense? So the one good example for why we need something that's something like standardization, everybody remembers their SATs.
Unfortunately,
And everybody remembers their ACTs.
I didn't take them.
I took the SATs, and I think I got like a 9-something, 980. I never took the ACT though. So everybody knows that the SATs, right? I believe they go from like 400 to 1600, right? And the ACTs go from like 10 to 40, I think, something like that, right? So every once in a while, when people start talking about their SATs and their ACTs, you'd want to compare them, right? They'd want to compare them and try to get like who did better, right? But because they are measured differently, you can't compare them. Got it?
Yes.
How did you get those money signs, bro?
Huh? What about money signs?
Yeah, bro.
Oh, oh man.
Right? Oh my god. Oh my lord. You guys are having way too much fun with this now.
Continue.
Yeah. All right.
Yeah.
So you can't compare SATs and ACTs because they're measured on different scales.
I mean, you can, it just won't go very well.
Yes, exactly. So the way that we do it is we basically match up averages and standard deviations and look at how they did within each test. And that's the point behind standardization. So that we can grab things that are measured differently, yet still compare them basically under the rules of statistics rather than the values themselves. Okay? The way that we do that is we turn everything into what's called a z-score. And that z-score, there's a formula for it. The mean, value minus the mean divided by the standard deviation. The equation that you guys will see repeatedly, oh my God. The equation that you'll see repeatedly in textbooks is usually this one, x minus the mu divided by the sigma. Okay, and what z gives you, so what a z-score gives you is the number of standard deviations away from the mean that your data is. So I know that sounds really weird to say. Once we do some of the examples, I think it'll make a bit more sense.
The value of what?
What the z-score means, what the standard deviation, or sorry, what the z value, this thing.
No, I understand. So like, it's like value minus mean over standard deviation. So the standard deviation is like the number, you know what I mean? Like for like in the last one it was like 20, so it'd be like over 20, and then like it'd be like value minus 120 over 20, right? What is value? Like what does that stand for?
Value, that is the number that, let's say we're curious about a specific value.
Okay.
So in the let's use the previous example, right? The previous example, the mean, right, was 120.
Yeah.
And your sigma was 20, right? Then your x can be any value you want it to be. So let's say we wanted to find out if a weight of 110 was weird, right?
Okay, I get it now. I get it now.
Choose X to be that 110.
Okay.
Okay, so let's check the understanding really quick. How many? Okay, yeah. That was a bad idea. Okay, there we go. Okay. Suppose that you took a test and got 85 out of 100, right? And the class mean was 75, standard deviation of 10. A friend of yours took another test and they got 16 out of 20. And that mean was 10 and 5. Does that make sense? So notice how this is exactly sort of like the example that I gave. One test is out of 100, and the other test is out of 20. We shouldn't be able to compare them too well. So instead, what we're going to do is we're going to compare them based on their means and their standard deviations and see how many people did better that way. Got it?
Why you didn't mark to 16?
Well, that's
okay.
Because of the 85 was the score there and 16 was the score there. Okay. Yeah, so what I'm going to do is this. I'm going to make 2 normal distributions over here. One there. And one right below it. Okay. So the first one's going to be our class that is out of 100. What's my average and what are my standard deviations up and down? So for the test out of 100, what's my mean?
100.
75.
Oh, that's going to be 75. And tell me my 3 that go up.
85, 95, and 105.
And the way down.
65, 55, and 45.
Right. Got it? And for the class out of 20.
The fuck?
What happened?
How'd you do that?
Wow.
No, my notes closed. My notes crashed.
I can't believe you've done this.
I know, right?
You guys want to see my room?
Oh. Yeah.
Okay, it's really, really messy because I didn't pack any of my fridge.
Sure. Excuse me.
Boom, 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 boom. I'm vain as hell. You feel me?
Where is this room?
I'm in New Jersey right now.
Dang, okay. This is pretty good then.
What?
You being in New Jersey right now and this still working.
It's the internet, dude. What?
Well, I didn't think it was gonna be good though.
What?
I thought it was gonna be glitchy.
Have you ever? You play online video games, don't you?
Yeah, and those crash.
I think you just need to start playing better games.
I know, right?
I'll pay someone $5 a day. Fold all this shit for me.
$5.
Right, I'll pay $10.
Does that include the plane ticket?
You forgot about that.
You
How
know
much
what?
you pay for it?
I'll throw in 15 with the plane ticket, actually.
Oh my god. All right.
Upcharge you for quarantine.
Look at these fucking losers out here.
All right. So the class that's out of 20, what's my mean? What's my standard deviation?
Means 10. Standard deviations,
5.
5, yeah.
Yeah, so tell me my tick marks up and tick marks down.
15, 20, and 25 up.
Okay,
And
and
then 5, 0, and
-5.
does the -5 make sense in this case?
No.
Nah. Well, we'll write it anyway because just to make it the habit, right? All right. Who scored a higher percentage? Let's look at
We
just
did
the percentage.
85% and 80%.
Right. So the first one, we got 85 out of 100. That is the 85%, right? And the other one, we got a 16 out of 20, and that's your 80%. So this guy did better, right? Okay. Next class. Who scored higher relative to their classmates?
The 85 was a z-score of 1, and then the 16 was a z-score of 1.2.
Does that make sense?
Wait, how did he just know that it was a z-score of 1?
Because it says a z-score scales both scores to a common measurement, and then below, find each z-score to answer the question.
Right
He
ahead.
just used that equation and just like plugged.
Plugged and chugged.
Yeah. So the first one, we already see that here's the 85, right? Which is 1 standard deviation away. So let's go ahead and do the math for it. So the z-score, we actually are going to solve for the z-score in this case. So z is the 85 that we got minus 75 being the mean divided by our 10.
85 minus 75 divided by 10.
You guys see how that worked out?
Yeah.
Okay. So here's the nicer bit about all of these, this equation in particular. So 85 is so that 85, let me write 85 nicer. That 85 is 1 standard deviation above the mean. And the way we get that is when we did the calculation, we got 1 for the z-score. Does that make sense? Okay. And it is above the mean because this is a positive value. So likewise, if it's negative, we know it's what? Below the mean. Make sense? So now, let's do the next one. Z, whoa.
16 minus 5 divided by 10.
Z is equal to 16 minus what?
5.
Not
No,
5.
Minus 10.
Divided by?
5.
Right. This gets you 6 over 5.
Something 1.2. Above the mean.
Right.
This is 1. This is 1. So
So
when I did 16 out of 20. was it more comfortable?
Huh?
Better. So the one that did 16/10 had a better
Class.
percentage.
Right. So if we look at the math that we did up here, we saw that one standard deviation, right, was 85, right? Got it? If we look down here, this guy got a 16. That is above the 15 by a little bit, right? And we know that 15 is one standard deviation. So this guy actually did better. Got it?
This is such a fantastic question to wrap this class up on.
Yeah, I know, right? Unfortunately, okay, I actually want to show you guys how to do the stat crunch thing. Okay, so at this point, what we're going to do is we're going to switch over to stat crunch. You guys don't have to, at least not yet, but while you're listening to me, try to find another device so you can use stat crunch. So I can show you guys what's going to go on in there. I am going to skip. What am I going to skip? Let's see. Suppose that the distribution of chicken and wings. What? Ah, okay. I see. Okay, so I'm not going to do 2. I'm going to skip this one because this one's silly. So back in the day, in order to find z-scores and percentages, statisticians tended to look at a table. Instead of doing a table, we now have StatCrunch do stuff. So we're going to make StatCrunch do a bunch of this stuff now. Cool?
Mm-hmm.
Okay, I'm just looking around to see what is coming up. Let me see. Okay. Okay, suppose that the distribution of chicken eggs weights is normal with the mean of 2 ounces and a standard deviation of 0.3. The minimum weight for a jumbo egg is 2.5 ounces for a jumbo egg. Got it?
Mm-hmm.
What is the z-score for the smallest jumbo egg? So this is straight out plug and chug z. Tell me what to put in. Tell me what to write.
That's 2 ounces. And the
Two
deviation
go on the
at
bottom.
0.3.
I know that.
What goes on the bottom?
2.
What goes on the bottom?
2.
Not 2.
It's 2.5. It's 2.5 minus 2 over 0.3.
Yeah.
Right.
Okay, 2.5.
So this is going to be 0.5 over 0.3. Correct?
Mm-hmm.
which is equivalent to 1.66, and that runs over. I don't want to add another 6 because then I'm going to hell.
It's okay. It's a decimal point, so it's not the real number.
Not the real number, right? The decimal values don't count. So, how many standard deviations away from the mean is it?
1.66.
And is it above or below?
Above.
Above, right? This is a positive 1.66, so that means it's going to be above. Got it? So, 1.66.
Is it sunny in California right now?
Yeah.
Yeah.
Yeah, kind of. There's clouds. I'm in Concord, so that's why. Got it?
Can somebody get Dutch Bros for me today? I miss it already.
Wow.
So notice how they already shaded it in for us. Right there. So this is supposed to be our 1.66 above the mean. Cool?
Somewhat, yeah.
Okay. Everything above that 1.5, so the minimum weight for a jumbo egg is everything above 2.5, right? Above 2.5 grams, right? Is it grams or ounce? Okay. Now what I want to do is I'm going to show you guys how to actually type that in. Okay. So if we go to StatCrunch, make sure StatCrunch, there we go. Again, we're going to go to our calculator. You guys have already seen this already. So if we go to stat calculator, and go down to normal. What's our mean?
2.
2.
2. And what's our standard deviation? 0.3?
0.3.
0.3.
Okay. We need everything above, below what value?
Well, above 2.
Above. Oh, go.
Right.
Above 1.66.
Above 2.5, or if you used your z values, it's above the 1.66, right? So put that in, compute. What's wrong?
So
You have to sign the wrong way.
Am I shading in the right area?
No.
It needs to be greater than.
It needs to be greater than. So I'm gonna go here, switch it. And now we got our 0.47, right? Or sorry, 0.047. Got it?
Mm-hmm.
So if we go back to our thingamabob, mean is going to be the 2. The 2. Standard deviation 0.3. The x increase, right, is the 2.5, and we needed x being bigger or equal to 2.5, and we got 0.0477. Got it? Okay.
What is the difference between the Z and this one?
I was going to get to that just now. So if we go back to this, right? I'm going to put in the 1.66 thing. Right? If I use the z-score, I am now looking at it as 0, and 1. That is, let me go back to my notes really quick so I can write that in on the side. These two things are equivalents now, because we are now going to be comparing them based on their means and standard deviations rather than their values. So we've got this going on, right? We have mu plus sigma plus 2 sigma plus 3 sigma minus sigma minus 2 sigma minus 3 sigma, right? This is equivalent, so this is within your own data, right? Whatever data that you're looking at, this is based off of those measurements, right? Z-scores, the same thing. The only difference now is we're looking at how far away from the standard deviation our data goes, right? So then this is now going to be 0. This is plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Right? To the point where each one of these sort of match up. The only difference here is that we are comparing them based on standard deviations now, right? Rather than the actual data. So if we do the exact same thing in our stat crunch, if we use the z values, oops, I didn't share the right screen. So if we use the same z values now, right? Or sorry, if we use the z values, we get the same percentage. How many people did I lose?
But it won't. It doesn't matter which one you use because you said you get the same percentage anyway.
Exactly.
Either or in any problem, or like just this problem specifically.
If I so yeah, okay. So in the future, I'm going to ask, if I ask you guys something with the z value, I'm only going to ask you to interpret the z value. Does that make sense? You don't, it doesn't matter if, like, when you need to give me the percent. So when you need to get me this value right here, I don't care whether you do it by z or by actual data.
Okay, wait. So when would you care?
Never.
Okay, it doesn't matter.
Doesn't matter, yeah.
Okay, got it.
Like I said, I'll ask you to interpret the z value. So see how you guys, how we computed a z value up here. We computed a z value up here.
Mm-hmm.
So I'll ask you to interpret that, whatever that means, right? But I won't care how you get the percentages.
Okay.
So this right here is equivalent to 4.77%. And actually, we did it backwards just now.
Oh.
Not completely. So what I meant to do was this. So this one, part C, was asking us to mean and standard deviation for the probabilities of the egg. So this one should have been the 2.3 greater than or equal to 2.5, 0.0477, with the x being 2.5. And the one above it, this one was asking for standard normal curve. This one's the one that we were supposed to use 0, standard deviation of 1, greater than or equal to 1.66, the x being my 1.66, 0.0477, ...
Oh, so that's the difference between the two equations. Is one is the standard normal curve.
Right. One is using sort of standard normal curve, where we're talking about the distance from the mean in terms of standard deviations.
Oh, okay.
Right. And the other one, so that was the first one, right? That's this one I'm talking about.
Mm-hmm.
And the other one, this one down here, is talking about the normal distribution of the actual weights of the egg.
Okay.
And like I said, I'm not going to care too much about how you guys get your percentages. So like I said, this is a 4.77%. I won't care too much how you guys get these two. Just make sure you know how to get them. Okay, I'm going to skip D. Okay. I'm going to move the group work till after the weekend. But I will consider this section done. All that's left for you guys is the Unit 5 lab, Space Pen, let's see, what day is it today?
19.
19. How about we do 3, 1, 6.
That's when that's due?
Yep.
And we're doing that picture PDF thing?
Yep, picture PDF thing and submit it online.
You're going to open something up on Canvas?
Huh?
You're going to open something up on Canvas?
Yeah, I'll open up a link on Canvas for all that stuff.
Cool.
Okay. Cool. We'll do group work next week.
Right.
Besides that, we are done, I think. I'll stick around for maybe 10 more minutes to answer people's questions, whoever needs it.
When's our next test?
I don't know.
They
Is
cancel
that to me? I don't know.
classes on Tuesday. Yeah, we still had a class.
I don't know yet. In terms of the test, I don't know what we're going to
Last class.
I might make them take home. What I really wanted to do was to turn, there's the question of your guys' group tests, what to do with your group tests. Or sorry, group quizzes, since you guys don't have groups anymore.
We can do it through Zoom, I guess.
I guess we can do it through Zoom.
Don't give him suggestions.
Group tests are like free points, though.
They are. Did I put in your guys' group tests yet?
No.
Not yet.
No.
No.
People usually don't drop below 90% on those.
All right, I'm out.
Okay.
Yeah. Goodbye.
Bye.
See you guys next week.
Have a great weekend.
You
You
too.
too.
Be safe. Wash your hands.
All right.
Everybody heading out?
Yep. Out.
Bye.
Bye.
Bye, Julio.
What you got? Leon, Ruben. How you guys feeling for now?
Pretty good, pretty good. This is a bit hard.
I know. Were
So
you?
you're gonna have office hours next week, beginning next week.
Well, I have office hours right now. I just need to transfer into the room for them. That's it.
Oh, all right. So you already sent it out a link for the office hours?
So if
Oh, you go to dashboard, huh?
yeah, well,
And
not
then you go to.
I'm gonna go back over my lesson.
yeah, go into your Canvas page or the main page of for the class. It's gonna be right there. It's gonna be right up front.
Okay. I'll go to the
All right,
right.
you guys have a nice weekend.
All right, you too, man.
All
I'll
right.
see you on Tuesday.
All right.
Stop.